Hello mathematicians, puzzlers, and other curious people. In this video, we are looking at different forms we can use to express ratios. So I've got some ratios here. So for example, like 6 out of 10 is a verbal form for a ratio. Well, when we want to express that as a fraction, we can think about that as a part out of whole relationship. So 6 out of 10 is the same as 6/10. Now in decimal form, the first decimal place is the tenths, so that would be simply 0.6, also often read as 6/10. As a percent, we multiply the decimal by 100, that would be 60%. 8 out of 20 is another one, so as a fraction we can say that as 8 out of 20. Now that's a little trickier to put into decimal format, so one property we can use here to help ourselves out is that a fraction is a division problem in disguise. So I'm grabbing my calculator and I'm simply putting in 8 divided by 20 and I get 0.4. And if I multiply by 100 or move the decimal point 2 places as a shortcut for that, I would find out that that's the same as 40%. This next one is given to us in the form of a fraction, 4/12. Well, if we work backwards from that and see it as a part out of whole relationship, that's 4 out of 12. And we can use the same property that a fraction is a division problem in disguise and say, okay, 4 divided by 12 is about 0.33. Actually, the 3 is repeating. So one way we often express that is with the overbar notation. Then to express that as a percent, again, the multiplication by 100 trick, and we see that that would be 33%, and then still with the repeating 3 after this. Our next problem is 7/5, which if we express that in verbal form, that would be 7 out of 5. Now, the problem with this is that's not actually a possible part out of whole relationship. That would have to be something else going on for that to be a ratio that exists in the real world. It couldn't be that there's a group of 5 and 7 of them have a particular trait. That's not a thing. If you don't believe me, show me 5 rocks, of which 7 of them are the same color. But we can still put it in decimal form by using the property that a fraction is a division problem in disguise, by saying 7 divided by 5 equals, and in this case 1.4. And if we multiply that by 100, we get 140 as our percent. Similarly, 1.5 would be 150%. We could find that out again by multiplying it by 100. It's a little bit trickier to try to come up with a fraction for this. So I'm going to need some scratch paper. So what we've really got here is 1 and 5/10. Well, 1 is really 10/10. So that tells me we have 15/10 in all. So that'll do for a fraction form. And I notice here that that would be 15 out of 10, which is also not a feasible part-whole relationship. Now for 0.75 here, again, we can multiply by 100, which we can do mentally by moving the decimal point 2 places, and find that that would be 75%. And we can express this in fraction form by saying, okay, the 7 is in the 10ths place, the 5 is in the 100ths place. So this would be 75/100ths, which is the same as 75 out of 100. So that seems very possible. Now another thing we can notice is the hundredths. Like here we had 75/100ths is the same as 75%. So when we get 12% here as our next prompt, we can say, okay, that 12% is just 12/100ths, or we can express that in decimal form by bringing back the decimal point 2 places and putting it as 0.12. We can also then check and say, okay, tenths, hundredths, so this would be 12/100ths. Makes sense. Now from this fraction form, it's trivially easy to see that one verbal form of this ratio would be 12 out of 100. Similarly, this 200% here, again, we can divide by 100 to turn it from a percent to an ordinary decimal. So that would just be 2. You can put 2.0 if you wish. And as a fraction, we can write that in a few different ways. One way that comes to mind is to just use what we've been using and say, okay, if it's a percent, it's that out of 100. So that would be 200 100ths, and we would say 200 out of 100, which also is not a feasible part out of whole relationship. So if this were a real world ratio, this would have to represent something other than a part out of a whole. So that's a quick overview of some common ways of expressing some different ratios and how the different ways and different ratios relate to each other. Calculator!